Alright, you're welcome to Chemists class. This is the first class for Exodus chapter. I pray the Lord grant you grace. I pray as you listen and as you watch this video, you are blessed and retentive memory in the name of Jesus. Amen. Alright, this is Chemists Introduction to Chemistry. That is for Exodus chapter. You can find out that here is my symbol there for my name, the prof, so you can call me prof. Chemistry department, you can see it is Ekiti State University. Alright, so we'll be considering these following topics. Number one, historical survey of organic chemistry, and chapter 2, isolation like that. And I'm going to be giving us a lot of questions and the explanation as well. Okay, so first we consider the historical survey of organic chemistry. Historical survey of organic chemistry. See, yeah, historical survey of organic chemistry. All right, as far as your chemistry is concerned, it's very important you have the basic knowledge or basic understanding of chemistry itself. And in your first semester, it would have been very fine. You did justice to definition of chemistry, many things like that. But here we're going to be considering the second part. So when you are watching this video, I would like you to pause it. Don't be in a haste. You are doing OBJ in your exam, and if you're to be theory, thank God. But majorly it has been OBJ. And I will want you to, typically when you read this, I want you to assimilate and cram every of the word to word. The vitalism, wherever I'm pointing out, I want you to really pay attention. Take your pen, jot as many. You pause the video, you read it over and over again. Okay, so first is the historical survey of organic chemistry. As far back as 1700, most chemists believed that there were two distinct classes of chemical compounds in nature. This means namely organic and inorganic compounds. So I want to read through and I explain. Organic compounds were from non-living source. That was then. So you see, as far back as 1700, most chemists believed that there were two distinct classes of chemical compounds in nature. The word this signifies, is also called namely. If you've done your GST 101, you'll find out that is there. So also, namely organic and inorganic compounds, just like this. And organic compounds were from non-living sources. Man is composed primarily of organic compounds and surrounded by substances that are organic in nature. In the past, it was believed organic compounds can be converted to inorganic substances through heating process. Example of heating process is ammonium cyanate. Example, you have something like this. When you have the composition of ammonia. So here, when you have the bone, let's say you have the reactant and you have the product, C plus D, and we can have the heat process here. Let's say at 100 degrees Celsius. Yeah. So that's just a sample. A few to be mentioned. You see, in the past, it was believed organic compounds can be converted to inorganic substances through heating process, while inorganic substances could not be converted into organic substance. So here, we found out that it was believed that organic compounds can be converted to inorganic, but through heating process, while inorganic could not be. Now, this observation gives rise to a theory of vitalism. The theory of vitalism states that life and substances associated with life were not bound by law of science. So it says these life-connected substances are the vital force, that man cannot control. Those two statements are very important are too important to be neglected, are very important that you need to cram them, so in your exam you can do it to do justice when you see questions thereabout. You are doing OBJ, and it is recommended about tutorial. It has been tested that you apply 40 seconds for one question, okay, per question. You're gonna meet up. So, and you find out that, so this chemist you read through, and this was debunked by Friedrich Wohler. Sometimes it is pronounced Friedrich Wohler for remembrance. Friedrich Wohler, a German chemist who formed an organic compound urea and an end product like that. You find it, and by eating an inorganic compound ammonium cyanate in 1828. So this Friedrich Wohler was a German chemist who debunked this theory of vitalism. And what did he did? He formed an organic compound urea by eating an inorganic compound ammonium cyanate. The word cyanate there is from alkanoid family, like that. And you find out that the compound he did was simply, he just do it to, you see, what he did was balance this should be positive, yes. So sorry for that. This is ammonium, and this cyanide. So this was the process he did, eating process, and which give him this. And in a nutshell also, you can also do it to write it like this. For simplicity, you can write it like this. There is ammonium, NH4 plus NCO under eating process will give you H2N, CO, and H2N. Yeah, I would explain this for you as time goes on when we get to organic chemistry itself, organic chemistry itself. You know, the topic says introductory chemistry 2. So I'm going to explain this very well. But you can write that equation like this. It's more preferred like this. So we've just learned so far now that year 1700, chemists believe some certain belief, and the classes of chemical compounds that are known are subdivided into organic and inorganic compounds. And this rise give birth, because you can't convert this guy, inorganic compound, you can't convert inorganic substance back to organic substance, so you can't convert this to this. This gives observation. This observation gives rise to a theory of vitalism, and we've stated that the first one, life and substance are still life and not bound by law of science. Number 2 says that these life connected substances are the vital force that man cannot control. So, and after very long experiments, this theory of vitalism was debunked by Friedrich Wohler. For simplicity, you can see Friedrich Wohler or Friedrich Wohler in year 1820. You can see the year distance. The year distance is a bit far. You can see that is almost a century. That is 100 and above. You're gonna calculate that year. That would be let's say that would be 128 years interval later. Before Friedrich Wohler arrived. So that means that process, that theory of vitalism, has taken place for a while. So this Friedrich Wohler debunked it by forming a particular urea organic compound called urea, and which give birth to ammonium cyanate. So you can find this out, ammonium, and you can have your NCO in place of it, and you have H2, and you have CO and NH2. So this is ammonium cyanate itself. This is ammonium and this cyanate from the word alkanoids, and you have this rubber. So also you can represent this I will explain this in later class, but just a brush up. You can have this as your R, CO, R, like this. This name of a compound, this is a name of a functional group. So this functional group, this family is called alkanone, or you can call it ketone. We have alkoxy, we have aldehyde, like that. So this is called alkanone family or ketone family, whereby your R here is just representation of alkyl group, and this is a functional group. When we get there, I'm going to explain homologous series, and these are mine. So this is ammonium cyanate itself. All right. So you can write this, like I said, as the other part I just finished now. And back here, organic chemistry. Organic chemistry is a study of compounds that contain carbon. Note there's no only there. Organic chemistry is a study of compounds that contain. Yeah, for more exposition, if you consider LAMLAD is very one I recommend for you all as my student. And you can see here, organic chemistry is a chemistry of compounds of carbon, except simple ones like oxide, carbide, and carbonate. The term organic is a relic of the days when it was thought that organic compounds would be produced only by living organisms. That was the year 1700. This idea was, however, proved wrong when Friedrich Wohler, you can see the spelling here, this is the right spelling. Friedrich Wohler synthesized urea by heating ammonium cyanates in 1828. After this urea synthesis, chemists have synthesized many carbon compounds, many of which have no organic origin in areas of dye, plastic, textile, fiber, detergents, perfume, medicine, and drugs. All these compounds of carbon are still called organic compounds. Organic compounds are important to humanity for two major reasons. Many of them play a vital role in the chemistry of living things, and also many of them are useful. Example, food, fiber, plastic, perfume, and so on and so forth. So I'm showing us here that the definition, different varieties definition of organic chemistry. So it's very, very good you are aware of this. So it's very important you really focus on this material, on this, and because it is with this material you're gonna set question, and it's very important you read vastly as well. So I recommend to you LAMLAD chemistry to get, okay? Alright, if you say you have ABABIO, very fine, but LAMLAD is preferred for questions. If you want to do your JAM, OBJ questions, you want to do your WAEC, it's very fine. You can get ABABIO and Essential like that, but preferred for more survey exposition, you get LAMLAD chemistry. Okay, so organic chemistry is the study of compounds like carbon. Organic chemistry is related to other branches of chemistry. As illustrated, you have the branches: biochemistry, inorganic, physical, nuclear, cellular. It's very important to know all these things. Development of organic compounds. Living things are largely made of organic compounds. There are other large number of other substances that we use or see around us every day, with about 100,000 new organic compounds discovered and prepared each year. Example of this, I told you, like we've seen before, are example like dye. Like your dye, you have your plastic, thereabouts, like that, and other compounds that are still coming into existence. Unique nature of carbon atoms. Carbon atom can form strong bond with themselves to form stable continuous chain by process catenation. So catenation is a process whereby carbon join together to form a strong bond chain, stable continuous chain. The chain can be a straight and open, as in acyclic compounds. Example is this. This is acyclic compound, a carbon that is on a straight line, that is on a straight chain. And you know, from alkene family, alkene series, I'm gonna list that for you. You always have 4 compounds or 4 hydrogen that is always surrounding a carbon atom, because carbon itself is the number 6 in periodic table, and you have it as 2,4. You have the electronic configuration as 1s2, 2s2, this is 4, and 2p, this is 2,4, remainder 2, 2p2. So you can find out that that this man here we surely need. How many compounds do you think it needs here? If you draw your the show out, you see that it needs how many? 4. From 2p2, it needs how many? It needs 4 electrons to complete 6 for p orbital, and you also have it as 2, 4, 1, 2, 3, 4. So you need how many? You need 4. So for carbon to complete its octet structure, you need 4 hydrogen to surround it, or 4 molecules. So you can have carbon. A single atom carbon must be surrounded by 4 hydrogen. So this process gives rise to single bond, double bond, and triple. So we have single acyclic that are surrounded by 4 carbon, 4 hydrogen. So you can have your hydrogen here, hydrogen here, hydrogen, hydrogen. It's very important you are aware of this. And you see the name of this compound is how many carbon? 1, 2, 3, 4. This is butane. Butane. I'm gonna name the alkane family series for you as we go on. Okay, so we have carbon can form. This is catenation. When carbon join together to form a continuous stable chain, they are more stronger like this than a single atom. So also you can have them in ring form. Ring form can be in terms of benzene. See, like this. This is a ring form. You can even as well as do it like this and draw it like this. You see, 1 like this, 1, 2, 3, 4, 5, 6. Benzene. You can even try draw it. This is in form of just 1, 2. The benzene part will be if you put this string, I double this string like this. So this is benzene. But moreover here we are not considering benzene in terms of its benzene. You can call this this is a circle. And you can call this cyclohexane. This is just a simple cyclohexane. Okay, so we have single bond and we have single bond and double bond and triple bond. So you can see from here, compound carbon can be joined to another carbon by single bond. This is a sample. This is just ethane. This is ethane and ethane. And also for single bond, I'm going to show you when you come to molecular series. The single bond example like this is just 18 because it's a single bond in family. If it's double bond, let's say we have this, you have 1, 2, 3, 4 to complete for this. 1, 2, 3, 4. You see, you have 1, 2, 3, 4 to complete this. You don't put this. This is very wrong. It should not be 5. Okay, it should not be 5. It should be 4. Make sure you are counting it. 4 surrounding. 4 surrounding. This is ethane. It's 18 rather. 18 rather. 18 family. This is single bond. Single bond. Why this is double bond rather. What is single bond? And if it's triple bond, you can have it as 1, 2, 3. You see, this is 3 carbon. So you can have 1, 2, 3. It only have 1 carbon. 1, 2, 3 meaning 1 to be 4. So therefore, this can be ethane. And this is triple bond. We also have other series like that, which we're going to put into consideration as we move on. Okay. So you do well as well to read this. And also another definition for hydrocarbon is that you can see these are characteristics of carbon, unique nature of carbon atom. Carbon form bond with hydrogen to form a special class of organic compounds called hydrocarbon. And hydrocarbon can also be defined as atom or as any compound that comprise only carbon and hydrogen only. So importance of organic compounds. You do well to do justice to read them. Any question you forward it to the group message. Okay. And also here are the composition uses of some hydrocarbon. You do well to do justice with example acetylene C2H2. This is also let me show you something. From C to H2, you can find out that C to H2, if you're going to draw the structural formula, that is carbon has 2 like this, and you can find out that hydrogen is 2 there. So you should know this is triple bond, because hydrogen is how many there? 2, and this is it must be 3 bond. Carbon is 2. Even from here, you can make use of the formula. Example for a family, that is for alkane. The formula is CN H2N plus 2 like this, and if it's alkane, you find the formula to be CN H2N. If it's alkyne, that will be CN H2N minus 2. So you can see CNH, these are all subscript and subscript. So you can find out that for this acetylene, which is C2H2, that means if I'm going to put the formula for alkyne family, that means applying CnH2n minus 2, sorry, CnH2n minus 2. I'm going to apply this. You can do it too. If I put 2 here, that will be C2H2, that is 2 times 2 minus 2. That will be C2, this 4, H4 minus 2, and this will be C2H2. So you can find this like this thereabout. So you can see, so C2H2 is alkyne. So this is ethyne because it is 2, and from the family series you have methane, ethane. So this is ethyne. So you can find out that we've just discovered and unraveled that acetylene is also ethyne, okay, and it is used as fuel of high temperature. Example, that is acetylene welding. It is used in welding. All this if you want to using oxyacetylene is a flame whereby it can weld two iron metal together. It can breed them together. It's very, very hot, high temperature. And we have the natural gas, which is a mixture of volatile hydrocarbon. Their industrial use, the CH4, C4H6, C4H10, there about propane, butane, and propane here is C3H8. It is C3H8. C3H8. Okay, and we have the paraffin wax, we have the kerosene, we have the gasoline butane. Okay, so you can also do justice to the reading of this remaining one. Any of the questions you have there you don't understand. Example, let me explain chlorinated hydrocarbon, that is hydrocation, react with halogen. Example, chlorine at high temperature ultraviolet to produce chlorinated hydrocarbon. When hydrocation, that is hydrocarbon, react with halogen, it tends to produce chlorinated hydrocarbon, and this can give us CCl bond. That is a single bond carbon attached with chlorine. It will disengage the hydrogen there. When we come to more of those classes, you understand very well. So just do justice to brush this up, and look forward to the next class for unraveling all these these bonds and these likes. So here we have organic compounds are useful, such as vinegar as ethanoic acid. This is vinegar. Example, organic compounds are useful for this: alcoholic drink, sugar, glucose, that is C6H6O12, and polyethylene, polythene, packaging, nylon, antibiotic, insecticide, cosmetic. So nomenclature, a logical system of naming organic compounds termed Geneva system was developed in 1892 at an international meeting of chemists in Geneva, Switzerland. This is a conference meeting for the chemists, whereby they come together and to come make a particular logical system for naming organic compounds. So later, In 1930, this system was revised and extended at another meeting of chemists in Liege, Belgium, at the convention of the IUPAC, that is the International Union of Pure and Applied Chemistry, organized by chemists. A revised standard called IUPAC was evolved. So, the main feature of the IUPAC system is that it assigns numbers to carbon atoms to show where various R, the word R there means alkyl group, are located along the main carbon chain. So you look forward to the next class for naming organic compounds by IUPAC method. That is the methodology. Okay, and we're gonna have, you see, so also before the next class, I want you to do justice to learn this. You see, number one, this is the first 10 member of alkane series with general formula CnH2n+. The first one we have is methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. We also have the next one, the 11th one. The 11th one can also be called, the first one there is methane and ethane. So you can call it simply, after decane, we have on decane. We have on decane. From the word on, do tracker, that is your French. And you can also just have it as me decane, or you can say or me decane. To signify it is simple, it is single. And we have number 12 as, this is ethane. So you can have et decane. You can call it do decane. That is using the French terminology. Or you can call it et. That is et here. And you can put decane there. Like hyphen, bridge it up together. With this, your propdecane can also be propdecane, or you can call it tridecane. So if you come, let's say number 16 now, you can say this 16 from the word is hexane here, right? So you can say hexadecane. Do you get what I'm saying? So if it's 17, you can say heptadecane and thereabouts. Also, do you get what I'm saying? So the first 4 members of the alkane family are majorly. So you can see here, characteristics of alkane family. Alkanes are aliphatic hydrocarbons. They form a homologous series of saturated hydrocarbons with this general formula. They are tetrahedral in shape. But my main point here is that they have the suffix in. The main point here is that the first 4 members are gases. So the first 4 members of alkane are gases. Liquid appear with the pentane, and from hexadecane onward, the members are solid. So here is a typical table to illustrate that. You see, this methane, ethane, propane, butane, these first 4 are gases, and from pentane downward till hexadecane, they are liquid. So you can see I identify here in the textbook hexadecane, and these are boiling points, they are melting point, rather boiling points, and relative density. And this is about alkane in a nutshell. And they used to undergo majorly, they undergo combustion and substitution reactions. Okay, so that is that about that, guys. And I'm going to be teaching next class how to name organic compounds. We have a lot to cover, and we'll soon be through. And talking about the naming, I'm going to explain that. And an organic compound whose longest chain contains 10 carbon atoms as the parent name, decane. That's a sample. And also, let's move here to classes of organic compounds. Class of organic compounds is subdivided into, there are over 10 million known organic compounds. Organic compounds which contain only 2 elements are known as hydrocarbon. Hydrocarbon are classified into 2 main classes, named aliphatic and aromatic. See, I come again. Organic compounds which contain only 2 elements. The 2 elements are what? Hydrogen and carbon. Only are known as hydrocarbon, and they are classified into aliphatic and aromatic. See, here is a pictorial diagram. Hydrocarbon is divided into aliphatic, aromatic. But don't forget, this is hydrocorganic compounds, and we have it here as aliphatic, aromatic. Aliphatic, the word aliphatic here signifies that we have acyclic and cyclic. They are just generally alkane family. Alkane family. The word aliphatic here majorly for as acyclic, we have alkane, alkene, alkyne. Cyclic can be cycloalkane, cycloalkene, cycloalkyne. And the aromatic here is benzene, polynuclear atom. The polynuclear atom can be naphthalene, anthracene, xylene, toluene. See example, let me show you something here. See, aromatic compounds from petroleum. We get aromatic compounds like benzene, toluene, xylene. The processed product are synthetic fiber such as nylon, plastic, insecticide, detergents, and solvent. So aromatic compounds are another polynuclear aromatic. We have them, and they are just generally under class, and aliphatic are also under class. So yeah, we're going to stop here. And finally, I want to know the important classes of hydrocarbon. These are some general formula that are very important for you to know before we move to major classes of organic chemistry. Alkane has this formula, CnH2n plus 2. Example is methane. If you apply, methane is 1. When you put 1 here, you have CH4. So cycloalkane has a formula as alkane, and that is CnH2n. Example is cyclohexane. You put 6 there, you have the formula alkene, CnH2n, and it can also be called ethylene. And ethylene here signifies 18. Alkyne is CnH2n minus 2. You have it as acetylene. And aromatic as C4R plus 2H, 2R plus 4. That is benzene example. If you put there, you're going to have your answer there. And N is the number of carbon atom. R is the number of ring. Okay. So we're going to be stopping here. And for next class, we look forward to the naming of organic compound with organic chemistry. Alright. So you have a wonderful day, and you do what to make sure you subscribe, and your questions, ask them. I'm going to be dropping the comment box. You drop on the comment box if you have any question there, and on the group majorly is to answer the question. Alright, so you do what to read ahead. There's no time, and you practice it with timing. Okay, alright. And in next class, we're going to be considering isolation and purification of organic compounds. Okay, before we go to organic chemistry itself. Okay, O Lord, we thank you this day. We exalt your name. We say, take all the praise, all to the end product that will become more closer to you. Say, be glorified above all things. We say, O Lord, regarding our learning, you help us all. We are not shy about it. We say, in this condemned world, we say, O Lord, also help us maximize every of this potential, bringing souls for you, O Christ, our Lord and Savior. We thank you, Lord, for your exalted above all things. For in Jesus' name I pray. Amen. Alright, have a wonderful day.